Welcome, math, growth mindset, math side, Panthers. Welcome to the third installation here, part 3 of volume. Finding the volume of prisms, rectangular prisms with using cubes, not so unit cubes necessarily, but fractional length cubes and so on. Also, determining how many cubes are in a specific box when you have a specific volume, given, either the dimensions given or the volume itself given. Here is the power cancellation. Canceling is going to be so helpful for you forever when you do math. It's such a powerful tool. It makes math so much easier when you can like find these little kind of tricks to kind of like simplify your life in math. So here we go. Buckle your seatbelts. We're about to take off. All right. Oops. You can't be saying that. Let's just kind of tell these people to leave me alone for a wee bit so I can get this video recorded. I get distracted too easily. Here we go. All right. So find the volume first. Let's find the volume of this. Not first. This is what we're doing. So I'm going to show you a trick to make it easier. There's a few things you could do here. What did I do in this case? Oh, I put everything over 1. In this case, right? 4 over 1, 5 over 4. How did I get that? That's where you take the 4 times the 1, and then you add the 1 on top. That's where the 5 comes from, and the 4 stays the same on the bottom. So that's where all that happens. Okay, but you can do it this way. Let's see, what did I do next here? Oh, I noticed that this 4 and this 4 here cancel out. Watch this. So I can cross them off. And then I could just multiply. 5 times 2 is 10. And then remember, this 4 is gone. So I can do 1 times 1 is 1. And so the answer is 10. That kind of makes that easier. I suppose you could have, if I back up here, you could have, should have, would have, maybe. Let's see if this other way is even easier. I could do the 4 times 2 first. All right. And then if I did that, I don't know why I keep losing my volume. It's a bit annoying. But anyway, I get 4 times 2 is 8. But remember, I still have to multiply that 8 by this 1 and 1/4 times 1 and 1/4. So I'm still going to probably need to kind of bring these together. That's going to be 4 times 1 plus 1, right? 4 times the 1 plus the 1 on top. That's going to give us 4 times 1 is 4 plus 1 is 5. And that's going to stay over 4. Because if it's a denominator, we're just breaking this into fourths. We're saying, how many fourths are in 1 and 1/4? Well, 1 has 4 fourths, and 1/4 is 1/4. We just add it together and get 5 fourths. So that's also where this comes from, 5 fourths. Then we still have to multiply that by 8 over here. Now, oh, we can still do it. Because if you put 8 over 1, now here's a little bit different way of doing it. You can see that this 4 goes into 4 one time. This 4 goes into 8 two times. So we're basically turning the 8 into a 2 and the 4 into a 1. Now when you multiply, you get 10 over 1. And you still get 10. I'm just saying it's not always, this may not make sense now, but just kind of plant a seed that eventually you'll start finding things like this and you'll start catching them, and later on, and maybe even sooner than later, you'll be implementing this kind of little trick here to help make your math life much easier. So just hang in there. It's not as obvious as this one, right? So when you see something glaring at you like, oh, 4 and a 4, that's like simple. That's like a no-brainer almost. This one's a little bit more of a brainer, but it can still be done. All right, so hang in there, you'll get it eventually. Don't give up. Don't do it. You stop trying, well, let's not go there. Let's just keep trying. All right, so let's see what else kind of other ways you can find some tricks to make multiplying fractions easier. We can stay away from those big numbers if we can. We don't have to simplify and all that stuff. Okay, here's another one. 2.5 times 2.5 times 4. Okay, so I guess I turn these into fractions again. I guess you have to in this case. I mean, you don't have any two whole numbers up here. So let's keep going with this. Look at this. You can do the 4 and the 2, right? And you can say, well, that's a 1 and that's a 2. Okay, so you could do that. That cancels. Then you got another 2 over here, 2 and 2. So they can cancel out. It's like a fun game, right? Like Sudoku or something. So what are you left with? 5 times 5 is top. Remember, we already canceled this. Gone. He's gone. 25. And then what's on the bottom? Just this one and this one, because this is gone and this is gone. So we have 1 times 1 is 1. So and that's just 25. That makes life easier, because if you didn't do that, you'd be doing all kinds of big numbers. And who wants to do that? Not me. If you didn't do that, you'd be back here, you'd be going like this. You'd be going, oh, 5 times 5 is 25. 25 times 4 is 100. Which, actually, that's not too shabby. 2 times 2 is 4. Now you got to divide 100 by 4, and you can say, oh, that's not too bad actually. 4 goes into 100 25 times, but I still prefer this. Actually, you know what's even easier? I don't know if you caught this. If you can catch this, this is even better. Wow, you may have caught this. This is even better. Even better. Oh, I love it. If you take this 2 times 2, you can turn that into a 4, right? And guess what? So basically you have, I'm going to rewrite all of this so you don't get lost here. We got this 5 and the 5 still. I got 5 times 5 on top. I still have times 4, right, on top. Now on the bottom, remember, we took that 2 times 2 and made it a 4, right? So we have 5 times 5 over 4, but then we have 4 over 1. Now look at that. Isn't that nice? Basically, we just take that 2 times 2 is 4 and cancel out here. The 4 cancels out with a 4. Now all we have to do is 5 times 5 is 25 over 1 is 25. So let's give another example. You guys getting the hang of these things, start catching stuff like this. Make your life easier in math. What about this one? Okay, so length times width times height. This time I did this first. You don't have to do this first, but I did. I did 10 times 2 first, got 20. But remember, I still got to multiply by this here. Okay, so now I'm going to convert this here into an improper fraction. All I did is I took the 2 times the 3, which is 6, and I added the 1 on top. That's where the 7 comes from. I'm turning this all into halves, is what we're doing. So this is 7 halves. We're saying that 3 and 1 half is the same thing as 7 halves. Okay, so then, ooh, we got a 20 up top and a 2 on the bottom. If you catch that, what can you do with that? Think about that for a second. How can we make these numbers simpler so that we're not multiplying 7 times 20? If you catch it, you can say, okay, 2 goes into 2 once, 2 goes into 20, 10. It's like, basically we're just saying it's like 20 divided by 2 equals 10. But you still got to have this like little placeholder over here, right? 20 divided by 2 divided by 2 is 10. Okay, so that's so much easier. 7 times 10 is 70. 1 times 1 is 1. Dun, dun, dun. Da, da, da. Nice little trick. Oh, I got one more, I think, for you here. See if you can do this one without me. There's several ways to do it. And if you find a different way that I'm not showing you, email me because I want to see it. I love seeing different ways of doing the same thing. That's one of the most magnificent, wonderful things in math for me. It just gives me so much incredible joy to see that happen. I know, I'm a little weird. By a little, I mean a lot. Okay, so this is one of the ways I'm doing it. 2 times 4, 4 times 2. Bring this down. Okay, so 2.5. How many halves is that? If I have 1, 1, 2, and I have a half, right? This is the half. There's the 1, 2. This is 1. That's 2 halves. A half and a half is 1. Another half and a half. Well, that makes the 2. So this 2 here, see, 1, 2, how many halves is that? That's 4 halves. 1 half, 2 halves, 3 halves, 4 halves. 4 halves plus 1 more half equals 5 halves. So the little kind of algorithm, I guess, if you will, is 2 times 2, which is 4. That's where this comes from, 4. And then plus the 1 half, plus the 1 half, this is the plus the 1 half, gives us 5 halves. Okay, so this is 5 halves. This is going to turn into 5 halves times 8. 5 halves times 8. If I put 5 halves, I put the 8 over 1. Now, see if you can find where the trick would go here. How can we kind of cancel some things out, so to speak, right? Or reduce, I guess it's called. Well, I'm going to give you a hint. It's with these two numbers here. What can we do with them? I guess they're not really numbers because 5 halves is a number, 8 is a number itself, 8 over 1. So I don't know what you call them. I guess you just, with these two digits? I don't even know what the right word is. Anyway, with these two thingy-majiggies, yep, if you got it, 4, because 8 over 2 is really the same thing as 4 over 1. Ah, that's where that 1 comes from. So we got to have, that's where the 1 and the 4 is here. Okay, so 5 times 4, 20. 1 times 1, 1. Because we already canceled this out, right? They're not there, so to speak. All right. Yep. 20. Oh, this is another belonging thing. Anyhow, 10 minutes is up. Everybody, pride, passion, purpose, Panthers, Hoffman out.